Hello everyone, welcome to this video. My name is Amir Sinahari. I'm a Google Earth Engine expert. In this video, I'm going to show you how to upload shapefiles in the Google Earth Engine platform. This is a basic tutorial that is very useful for the beginners, for those of users who want to upload own shapefiles in the Earth Engine and clip the data and export the results based on the input shapefiles. In the previous videos, I showed you how you can deal with the satellite data in the Earth Engine platform. Now in this tutorial, I'm gonna show you how to identify your region of interest using your own shapefile. This is a very simple process. Just go to the left panel under the assets here, through the new button. You can upload own shapefile or GeoTIFF or CSV file. For example, I'm gonna upload a shapefile for a basin that I'm gonna study. Here, through the shapefile, go to a new page, click on select, then you can browse on your system and go to the folder. You have your shapefile. For example, I have a shapefile for one of the basins in Iran. As you can see here, this is Urmia Basin, and this is a shapefile with different formats. SHP, PRJ, DBF, and SHX is available. As you can see, for the Earth Engine, it is necessary to select SHP, SHX, click on Control, and then select the formats like DBF, PRJ, SHP, and SHX, all of them together selected, and then upload it. And select the assets ID that you have. As you can see here, you have a cloud project and you have assets actually, or legacy assets actually. So I'm select the legacy assets, and you can change its name or you can keep it as it is. For example, I'm gonna change it to test basin, for example, and then click on upload. In the right panel under the task, you can see one unsubmitted task that is running on the browser. So you should wait until the uploading process is done. So as you can see, it is uploading. For the shapefile, the process of uploading is very fast, and after a few seconds, you will have access to your own shapefile in the left panel under the assets. As you can see, various study areas shapefile already uploaded on my system, and now it is very simple for me to have another one next to the existing shapefiles after a few moments. If there is any problem in uploading process, definitely you will face with actually errors or anything else. So as you can see, the tab turned to the blue color, meaning that the process of uploading was successful. And now go to the left panel again and first refresh, and now try to find the test basin. So as you can see here, the test basin is already available here. If you click on the test basin, you can have a preview about the basin's data characteristic and location. So this is Urmia Basin located in northwest of Iran, and now I'm gonna have this basin as a shapefile inside my code. For example, here, where is it? Where it is the test basin. There are three options here, and the first one is import. And if you want to share your code based on a shapefile, you must share it before through the share item here. If you check anyone can read, meaning that whenever, as long as you share your codes, including the table or including this shapefile, because it is already shared, the other users can also see your code based on the shapefiles you already imported through your assets. So click on done, and now whenever from now on, when I want to share my code through the get link and this link button, the table with the code will be copied and all will be accessible for the other users. So now I can have a look or quick look on a study area through the map.center object based on the table, and then through the map.add layer based on the table. So let's try with center object based on a table to see how center object works. If you click on run, you will go to the location of the table, and if you want to see the shapefile, just map.add layer must be used. Map.layer for basing. If you run a code, after a few moments you can see the shapefile in the right location. Or if you want to change its color, it is very simple. Just make a curved bracket like this and change the color to, for example, red, just like that. Run a code, and now you can see your region of interest with the red color. So the type of when you are dealing with the shapefile, the type of processing is is completely same as what you did previously. For example, there is no difference between satellite data analysis. There is no difference whether you have geometry or a table. The only thing is different that you can actually clip your study area based on your region of interest or a precise border, rather than have a rectangle or anything else. For example, here I'm gonna call muddy satellite data and show you how we can do this process. But it is important before going through the shapefile clipping and also shapefile using in your code, it is important to simplify the imported shapefile into Earth Engine, because you are doing process on the cloud and it is very necessary to actually simplify the data you are working. For example, if I get a print from a table just like this, table geometry, then in the right panel you can see this shapefile created from 5,000 vertices. That's too much vertices and also too much volume for the cloud-based data analysis. That's why it is important to do a kind of simplification on this table to make it more usable or applicable for the rest of the studies, because we wanted this region, the border is important, but we wanted this border with a simpler structure, so a lower number of vertices. This is very important. For example, I'm making a new ROI and then get the table layer here. As it has a feature collection format, you must make a loop structure to do the simplification for each part separately. Make a function, and each input feature could be called as a feature. The function returning, as you can see here, the function returning each feature while it is simplified, using that simplified and with based on a maximum error, for example 1000. Larger maximum error, lower number of vertices. This is very important things. For example, now I'm gonna have another map.add layer based on ROI. You will see two layers here that they are almost same and there is no clear differences between these two regions. But when I get a print from the ROI.geometry, definitely you can see the lower number of vertices. We have the same border, but instead of 5,000 vertices, we are working with 300 vertices. and that could be a beneficial item when you are going to work with the shapefiles in the Earth engine. It is very important to do the simplification before further analysis, because as long as you have a simpler shapefile, you can get you can have faster processing in the Earth engine, and it is very important to important thing to generalize your code and your application as much as it is possible, because most of the users now watching this video are scientists, researchers, and students, and I'm sure that all of you are using or dealing with the Earth engine with an unpaid version or open actually version or public version. And in public version, the resources we have for processing are two limits, and this is very important for us to write a code that can be run with the highest speed that is possible. That's why we need to care different things while we are writing codes to have access to better performance and better efficiency in the Earth Engine platform. So now I can actually call a satellite data and clip my region of clip the satellite data based on region of interest, and then get an export, for example, to see how we can use this ROI as an example. For example, here I'm gonna call modest temperature or modest LSD data. Just type modest temperature inside the box we have in the above. As you can see here, modest temperature product is available with different names. So I'm trying to use different names such as the modest LSD. Now you can see all modest LSD products listed with different temporal and spatial resolution. For example, I'm gonna select 1 kilometer data with 8 days interval. It is just an example to show that how we can use this shapefile for the further analysis, because in my point of view, to my knowledge, there is no clear differences when you are dealing with a rectangle or actually a shapefile. For example, when you want to clip, just the argument or just the input will change. There is no difference between clipping based on a shapefile or clipping based on a shapefile or rectangle or drawing tools you have here. For example, I make a variable as LSD equals to, so we have image collection here, and from this image collection, I'm gonna select the LSD bands. But in the previous videos on my YouTube channel, totally explained about how you can find your target data, how you can find the LSD bands or the target bands, how you can prepare your satellite data. Everything well explained in previous videos. Just in this video, I'm gonna show you how to deal with the shapefile instead of a rectangle or drawing tools in the Earth engine. But here, quickly, if I wanna point out here, if you go to the bands, you can find the LSD and also the scale value. And this is my target band, and then copy and paste it inside the code using the select as a function help us to select the target band. So then filter your data based on a period of time, for example, based on 2023 data, I'm gonna get an average temperature from this region, and then I'm gonna calculate the average temperature that is multiplied to the scale factor value 0.02. This is a scale factor that allows us to convert the integer or original value to the Kelvin formats, so the temperature unit I mean. And if you want to convert it from Kelvin to degrees Celsius, just subtract it from the constant value that is 273.15. As you can see here, this is a constant value, uses convert the temperature from Kelvin to degrees Celsius. So in the next step, use the map.add layer to clip the LSD based on your region of interest and visualization process. For example, I'm going to clip it based on a shapefile that is already simplified, that is ROI here. And then, so if you want to do visualization process, you can make a palette for the output. For example, I'm going to show the temperature range using 3 different colors. Lower temperature with the blue, the mid temperature with, for example, white color, and higher temperature with the red color. So, and the layer name will be LSD, and use the false at the end to avoid automatic visualization. That's again speed up processing in the Earth engine when you use the false at the end. So in the right panel, here there is a problem. Here we will have a palette. Oh yeah, here must be blue. And now I think the problem is solved. And this is the LSD layer, but to enhance the contrast, you must increase, or you must stretch the contrast by 90% of values. And when you click on apply, you can see the temperature variations over the region of interest. In the mountainous region, lower temperature expected, and also in the actually downsides after the mountains. Here you can see we have the higher temperature, and here we have a water body with a lower temperature, and area is completely clipped based on a region of interest easily. So now maybe you have a question how we can download this data or bring it out from Earth Engine and import it into the QGIS or other desktop software. This is the kind of questions that most of you asking about the problems and issues that you have when you want to bring data or transfer data from Earth Engine to QGIS. Now, through the export.image to drive, this is the best option to get an export from the Earth Engine. You can get export using different arguments. For example, the image I want to get export is LSD, but remember to clip it based on a region of interest. That here it is ROI. This is very important. And the output file name will be LSD data, just like this. And the next parameter is scale, should be equals to 1000, for example. The region of interest will be ROI. So here the CRS, the coordinate system, equals to EPSG 4326. This is the code for explaining coordinate system as or setting coordinate system as WS84, that is same for all around the world. Then you can set a folder or make a folder to save your data in the Google Drive. For example, I'm gonna save it in a test folder, just like this, and try to save your code and run it again. After a few moments in the task, you will have an LSD data that is ready to save in your Google Drive. And now you must actually wait a little wait until the process of saving is over in the Google Drive. Then you can pick it up from Google Drive and open it up into QGIS. Now I'm opening QGIS. As you can see, the LSD data is ready, and now I can go to the location in my Google Drive, and after a few moments you can see here it is. I'm waiting for Google Drive to be uploaded completely. Then I can pick up the shapefile. So back to the code, and QGIS is now, yes, here QGIS is opening. If you had any question or problem, you can reach me out on my YouTube channel and put your comments there. And also, if you had any syntax error, you can find the code available below the video in the description box on my YouTube channel. Yeah, just I will be appreciate if you share all of your questions on my YouTube channel, because there are a lot of questions and messages from different social medias, and so I'm unable to handle all of them. And I will be appreciate if you reach me out through the YouTube channel in the comment parts. So here in the, for example, now I must go to Google Drive. As you can see, the LSD data now is ready. In the folder we already named as a test here, it was already available on my Google Drive, and just throw a right click, you can download the output. Let me to remove the page, and this is the LSD data I'm trying to download, but unfortunately the speed of processing of my system is very low. It's because of the recording by a video screen. That's why speed of processing is very low. But definitely in your system it will be easier to download from Google Drive. Now, as you can see, we have a download option here. Click on download, and after a few moments the download process is started. So now I can go to QGIS just like this and click on open, or you can do this process in any other GIS based software that you are using. For example, I'm gonna call a raster layer and then click on a browse and go to the address that you already saved your data. Here, as you can see, I have LSC data already downloaded here. Open it up like this, and here, as you can see, this is a layer that I have enclipped based on the region of interest, and it is already georeferenced, because when I actually browse on an image, or when I pan on an image, you can see the longitude and latitudes in the coordinates changing correctly. So, but if you couldn't see your region of interest or the values on reflectance or temperature or any other visual characteristic perfectly like this, or if you faced with a black surface, there is a simple trick in the QGIS. Just go to the properties and increase the contrast here. Through the symbology, there are different methods for increasing the, for example, visualization contrast. For example, I can make a pseudo layer. As you can see, single band pseudo color. You can change it to a single band and select the target band here. You can see the minimum and maximum values, and there are different ways for the visualization or contrast stretching process to increase the contrast. For example, I'm gonna increase the contrast based on the minimum and maximum value. Otherwise, you can try with other techniques, such as here cumulative, for example, method is another stretching technique that helps you to increase the contrast. So if you faced with a black surface, or you couldn't see anything on the raster layer, the best solution is going to properties and increasing the contrast in the single band pseudo color. After selecting the band, increase the contrast through the actually this part of symbology. That is very helpful. And also you can try with different colors, as you can see all of them available here. So, and that was about the calling satellite data based on a shapefile, clipping, visualization, and bringing into QGIS. Now there is another solution for dealing with the shapefiles. Imagine that you don't have the table or shapefiles that I'm using, but you want to find your region of interest based on a borders, based on a, for example, shape basin borders, but the basin borders are not available for you. The good news is Google Earth Engine already provided access to several shapefile layers for basins, countries, provinces, and also there is a good option we have in the Earth Engine to select our study area based on the shapefiles and borders already available here. For example, if you go to the search places and dataset, the hydroshed layer is available. The hydroshed basin levels available from level 1 to level 10 with different detailed characteristics. For example, the middle level is level number 5 that I'm gonna visualize and show you how it works. And in case you have no access to my shapefile, then you can find it through the basins in the hydroshed layer. For example, here through the map.add layer, you can have a view from all the basins in this layer in the global scale. Click on run, and now in the map, you can see all the basins in all the countries. I was working with Urmia basins in the northwest of Iran. You can see that shapefile is also available here. It is very simple process if I want to have access to only this region or only this basin. For example, just we can select the target basin first and then throw the ROI equals to from inputs table that is hydroshed basin. I'm gonna filter based on the boundary of marked region. The marked region is the geometry. Then through the map.add layer, I can have access to ROI with a different color. The color is, for example, the red. And if you run a code here, you will see your region of interest as a separate layer, and you can continue your process and next steps easily without any issues. As you can see here, this is a good visualization properties and techniques that helps you to call your data from an external sources, rather your systems. And you can do this process for the basins and also the provinces. For example, if you want to find the province border, it is also very simple to use the FAO data here. If you type about the FAO administrative layer, here you can see that the FAO administrative layer is available in, for example, country level, in province level, and urban level. For example, I'm gonna actually select one region based on the province level. So for example, the selected region, I'm gonna actually have access to province border for selected point. So it is very simple. Make another variable as province equals to from the second table that is FAO administrative province border that filter it based on the boundary of geometry. If you run a code, then visualization you can see, and then through the map.add layer you can visualize province just like this. This is the province border, and you can choose whether you want continue your process through the basin layer or the province layer. And it is very important to do the simplification process same as I expressed before. And it is very important you do the simplification process whether you call your shapefile through your own system or you are calling the shapefiles through the FAO layers available in the Earth Engine or the hydroshed layers. I hope you got enough information about how to upload your shapefile and how to select your region of interest. And if you had a further question, you can reach me out on my YouTube channel and put your comments there. I will be happy to answer your questions. Thank you for your attention.